right, we're here for our last pit stop on density. I'm on page 8, so it's right after our heart and our density practice on 6 and 7. Okay, this is going to be page 8. Again, the paper will barely fit on the page, so if it's not trimmed down to fit, go ahead and trim it down as much as you need to get it to fit on the page. Our title is going to be Identity of a Substance. So we talked about how you can use the physical properties to categorize or classify substances, or like in our stop number 1, we used the luster, conductivity, and malleability to classify elements into 3 groups: metals, nonmetals, and metalloids. Density is another physical property, and it can actually be used to identify the substance. So for example, if something is really made of true gold, that object, no matter what it is, whether it's a little gold nugget or a big gold chain, it's always going to have a density of 19.3 because that's the density of gold. And so oftentimes we'll be asked to identify an unknown substance using its density. So at the top, that's what it says here, is you can identify an unknown substance by measuring its density and comparing your result to a list of known densities. So again, these are things that will never change. Calcium always has a density of 1.54. Carbon always has a density of 2.27. And so if given a problem where we have some unknown substance and also given a list of the densities of those substances, we can identify the unknown. So that's what we're going to do here in numbers 1 and 2. If we look at number 1, it says an unknown substance has a mass of 4.54 grams and a volume of 2 centimeters cubed. Using the chart above, determine the identity of the unknown substance. So I'm going to start with what I know. Here's the mass. Here's my volume. Okay, so I'm solving for density. I'm going to go ahead and set up my triangle where we divide on the side, multiply on the bottom. I know that my mass is 4.54. My volume is 2. And I'm looking for density. Okay, and then when I'm done, I'll find my answer up here. So I'm solving for density. 4.54 divided by 2. Top in, bottom out. So 4.54 divided by 2. So I'm going to put 2 into 4. 2 goes into 4 2 times. Okay, 2 times 2 is exactly 4. That gives me 0. I have a decimal here. It has to jump up, okay, before I can move on. I'm going to bring down my 5. 2 goes into 5 twice, 2 times. Again, 2 times 2 is 4. If I subtract, 5 minus 4 is 1. Bring down my 4. How many times does 2 go into 14? That's 7. 7 times 2 is 14. I'm left with a remainder of 0, which means I'm done, right? So my answer is that density equals 2.27. And remember, we use our mass units, grams, slash our volume unit, centimeters cubed. Now remember the question, though. The question was determine the identity of the unknown substance, not just find the density. I'm going to use the density now up here. If I look at this chart and I find my answer, 2.27 grams per centimeter cubed, that means that my unknown substance must have been carbon. Okay, so my final answer over here is carbon. Okay. If you think that you can do that on your own, stop the video right now, push pause, and try number 2. If you'd like a little bit more practice with me, go ahead and follow along with me. We're going to work out number 2. It says an unknown substance has a mass of 16.38 grams and a volume of 9 centimeters cubed. Using the chart above, determine the identity of the unknown substance. We're going to do the same thing that we did over here, starting with our triangle. We divide on the side, multiply on the bottom. I know my mass, it told me right here, 16.38. My volume is 9 centimeters cubed. So I'm still looking for density. If I follow this equation, 16.38 divided by 9. So I'm going to set that up over here, top in, bottom out. 16.38 divided by 9. All right, 9 does not go into 1, but it does go into 16. It goes in just once. Okay, 1 times 9 is 9. If I subtract 16 minus 9, I'm left with 7. Okay, I have a decimal that needs to jump up, and now I can bring down my 3. How many times does 9 go into 73? Well, I know that 9 times 8 is 72. So that's as close as we're going to get. So 9 times 8 is 72. Subtract, and I'm left with 1. Bring down my 8. How many times does 9 go into 18? That's twice. 2 times 9 is exactly 18. So now we have a remainder of 0, which means that we're done, and we have our answer. So density of this unknown substance is 1.82 grams per centimeter cubed. Now again, that's not our final answer. We've got to go up to our chart, look for 1.82, and here it is. The answer must be phosphorus. Our unknown substance is phosphorus. Now, if you were working out a problem like this and you came up with an answer that was not on the chart that was given, then it's most likely that we made a mistake somewhere in the math. So if you get like that on a test or on a quiz, my suggestion is start over, find another scratch piece of paper, do the math again, because this has got to be one of the answers. Okay, so be sure you're checking your work by finding it in the chart. All right? I'm going to move down to the bottom of the page. Okay. Another way that these problems may be presented to you is in this situation right here. It says the table provided shows the properties of 4 different sample materials. And actually, we'll change that to 3. The table provided shows the properties of 3 different sample materials. A student has a substance with a density of 1.28 grams per centimeters cubed. What sample does the student have? So the student either has sample 1, sample 2, or sample 3. What we're going to have to do is the opposite of what we did before. Rather than calculating the density and finding it on the chart, now we have to calculate the density here, and what we're looking for is 1.28 grams per centimeter cubed. So one of these answers should be 1.28 grams per centimeter cubed. Now, for the sake of time and for the sake of some of our math skills, on this one I'm going to go ahead and say that it is okay to use a calculator, okay, since we're doing quite a few at a time. So, we still have to go through and set up our triangle. We still have to, figure out what formula we're using, okay. So for sample 1, here's my triangle. Divide on the side, multiply on the bottom. For sample 1, my mass is 26. My volume is 15. I'm looking for density. Okay. So 26 divided by 15. Even when you're using a calculator, you've got to know the formula and you've got to know how to use a triangle, because if you do 15 divided by 26, you're going to get a completely different answer, and that's not going to be correct. Okay. So we're going to put into the calculator first 26, then divided by 15. 26 divided by 15. My answer is 1.733. We're not going to go any farther than 3 places after the decimal. And that was grams per centimeter cubed. All right. If we do the same thing for sample 2, set up our triangle where we divide on the side and multiply on the bottom. Okay, sample 2. Mass goes at the top, that's 23. Volume of 100 goes right down here. We're looking for density. Okay, again, we can use the calculator as long as we're using it correctly. 23 divided by 100. It doesn't matter that 23 is a smaller number. It still has to go first because it's always mass divided by volume. So my answer is 0.23 grams per centimeters cubed. Okay, same thing for sample 3. My triangle. Divide on the side, multiply on the bottom. Sample 3, the mass is 160 grams. The volume is 125. Okay, I'm looking for density. That means I'm going to follow this formula, 160 divided by 125. So I'm going to put that into my calculator. 160 divided by 125. And my answer is 1.28 grams per centimeter cubed. Now, ultimately, remember that the question was, which sample does the student have? If the student has a sample with a substance with a density of 1.28 grams per centimeter cubed, that's what I'm looking for down here, which is what we found with sample number 3. Okay, so the answer is that he has sample 3.